Okay, so they can make your life a little bit more difficult. Not really though. I mean, if you know how to do this, you won't be in trouble. So they might want to ask, find the number of atoms in 10 cm cube of mm, nitrogen gas. So the information that's given to you is the volume of nitrogen gas. You know the volume of nitrogen gas. So what you're going to do is we're going to use the third formula to calculate the number of moles present in nitrogen gas. So the steps should be like this. We find the moles from the volume. We're going to find moles of N2, and from there we're going to find number of molecules of N2, and from there we'll find the number of atoms of N. So first step is the volume is 10 cm cube, so we're going to find the molecule first, number of moles first. So we use the formula mole is equal to volume by molar volume. So we're going to assume that it's RTP. So molar volume is going to be 24,000 cm cube per mole. So it's going to be 24,000 cm cube per mole, and the volume was 10 cm cube. So 10 cm cube. Cm cubes would cancel out. So denominator of the mole is going to go to the top. So we have mole of N2. So from there, we need to find number of molecules of N2. So we take the number of moles of N2, we multiply it with the Avogadro's number, and we get so we get 2.51 times 10 to the power 20 molecules. So we have this many N2 molecules. So that means basically if it's hard to imagine, so this is how a nitrogen molecule looks like. You have a triple bond, so you have this many of these guys, nitrogen molecules. So how many atoms do you have? So in one molecule of nitrogen gas, you have 2 atoms of nitrogen. So the number of atoms, so the number of nitrogen atoms is going to be 2 times the number of N2 molecules. So we know that the number of N2 molecules is that. So we're going to end up with, so we're going to end up with 1.25 times 10 to the power, oh no, sorry, excuse me. So we're going to end up with 5.01. This is wrong. Well, let's just get rid of that. Let's just get rid of this bit. So you would have 5.02 times 10 to the power 20 atoms of nitrogen. So that's how we do it. So let's look at this problem. This is basically from the Pearson. This is IAL Jan 17, question number 16. So this is free. This is free media. I mean, they share it. Pearson shares it with everybody. So that's why I'm using this one, and I'm not using any of their like locked ones. So so let's look at this problem. How many moles of ions? Now look, they're not asking about how many ions do you have. They're asking about how many moles of ions you have. So it's a very important bit here. How many moles of ions are present in 30 cm cube and concentration blah 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 barium hydroxide solution. So as it's a solution, we're going to use our second moles formula. The second moles formula was, do you remember, it was moles equals to volume times concentration. So the concentration here is in mole per dm cube, right? So if you remember correctly, we need to use the volume. The unit of volume that we should use should be in dm cube. So what we're going to do is we're going to convert 30 cm cube to dm cube. So 30 cm cube is equals to 30 by 1000 dm cube. So we know the volume. We're going to plug that volume in here. So let's find the moles of that first. So 30 by 1000, I'm just going to say 3 by 100. So this is the dm cube times the concentration was 0.025. Concentration was 0.025 mole per dm cube. So this dm cube is going to cancel out this dm cube. So the number of moles you have is, the number of moles you have is 7.5 times 10 to the power minus 4 moles. So we now know the number of moles of barium hydroxide solution. So we're not done yet. They asked us to find the number of moles of ions. So if you think about it, so the barium hydroxide, right? The barium hydroxide. So let's think about it. What is it made up of? BaOH2 aqueous. So the barium hydroxide solution is made up of one barium ion and two hydroxide ions. So basically, for one barium hydroxide molecule, we have two ions. We need two ions. So no, we need three ions. So we need three ions, one of barium, one of barium and two of hydroxides. So we need three ions, and three ions combine to make one molecule of barium hydroxide. So we have the moles of barium hydroxide here. So to find the total number of ions, what we're going to do is we have to multiply the number of moles of barium hydroxide by 3 to get the total number of ions present. So let's do that. So the number of moles, the number of ions in barium hydroxide is going to be 3 times 7 2.5 times 10 to the power minus 4, which is 2.25 times 10 to the power minus 3, which is basically answer choice C. So this is the correct answer.